morning, children. We proceed on to chapter 7, differential calculus and its applications. Last chapter, that is in 5th chapter, we learnt about tangent and normal to parabola, circle, ellipse, hyperbola. Now this chapter, again we are learning tangent and normal, but now it need not be exactly parabola, all that. It can be any curve. So any curve, even I need not even know the shape, all that of the curve. Whenever they give you an equation of the curve, I need tangent at a particular point. What should I do? Differentiate the curve that is given. Substitute the point that I need. And this I call slope of the tangent. So very important idea. From differentiation, I need not know the equation of parabola, ellipse, hyperbola, all that, and the variety of formula that we learnt in the previous classes. Differentiation gives us a very simple idea. Whatever may be the curve given, differentiate it. Substitute the point x1, y1 in that answer. Whatever I get, I call m, that is slope of the tangent. How to get tangent equation? It is a line. Tangent is a line. Look at this diagram. This is any curve. And this is a point x1, y1 on the curve. The line that is touching the curve at that point is called tangent. And that particular point, I drop a perpendicular which is called normal. So tangent equation, tangent is also a line. We know the point x1, y1 and we know the slope m. So what is the formula? Y minus y1 equals m into x minus x1. If I want, this is tangent. If I want the normal, it is perpendicular to the tangent. Use perpendicular and use that idea m1, m2 equals minus 1, or else the same formula I can substitute y minus y1 equals minus 1 by m x minus x1. Since normal perpendicular to the tangent, the slope will be minus reciprocal. So this particular exercise we are going to learn in detail. Equations of tangent and normal. Also, some special conditions. If the tangent is parallel to x-axis, or I can use the word horizontal. The tangent is horizontal tells me it is parallel to x-axis and I cannot measure any angle. The angle between tangent and x-axis is 0. In this case, dy by dx equal to 0. Suppose the tangent is vertical or parallel to y-axis, or I can say perpendicular to x-axis. In this case, dy by dx is undefined. So two special ideas. When tangent is parallel to x-axis, or I use the word horizontal, dy by dx is 0. And if it is at 90 degrees, dy by dx is infinity. Now given the tangent, you must know to write the point. Given the point, you must know to write the tangent. So different methods we adopt in the various problems which we will discuss in detail in this exercise. Certain formula what we learnt last year, we are going to recall to apply in the questions. The very first formula, x power n, remember it is n x power n minus 1. Derivative of x power n we call nx power n minus 1. So applying this, we often come across constant. What do you mean by the word constant? 7, 6, 9, half, e. So these things we call as constants which become 0. X will become, as I apply wherever n comes put 1. We get x is 1. X square, 2x. X cube, 3x square. So every time these things come, you must be familiar to answer immediately. Let us repeat. Constant becomes 0, x becomes 1, x square becomes 2x, x cube becomes 3x square. In general, any other power comes, apply this formula, x power n becomes n x power n minus 1. Coming up to certain special functions, 1 by x often will come, remember, minus 1 by x square. Root x also will come. Root x, the derivative is 1 by 2 root x. So regarding x, you must remember these things thoroughly to apply in the problems. E power x becomes e power x, very simple formula. Log x becomes 1 by x. Suppose I have e power 2x. My answer will be e power 2x into 2. So this we call chain rule. So e power 2x will become e power 2x into 2. Similarly, let us learn some trigonometric functions. Sin x will become cos x when I differentiate. Cos x will become minus sin x. Tan x, secant square x, sin 2x. Let us remember, sin will become cos. In the same way, sin 2x will become cos 2x. Hiding sin, 2x will become 2. Remember, this we call chain rule. Sin 2x will become cos 2x. 2x will become into 2. Similarly, sin square x, when I see, you remember x square. X square becomes 2x. So, sin square x will become 2 into sin x. Hide square, it is sin x. Sin x will become cos x. So, these are very simple formula that we recall, and there are some more. As and when the problems come, let us learn them. Exercise 7.2, question number 1. Find the slope of tangent to the curve. See, they have given at x is equal to 1. When I find the tangent, I need the point. So, if they give you x, you find out y by substituting here. Y equals to, when x is equal to 1, it is 1 power 4, 2 into 1 square minus 1. Or I simplify this, 1 plus 2 minus 1, which is 2. So, what is the point that I get? I take the point x1, y1 as 1, 2. X value 1, y value 2. To find the slope, let us differentiate with respect to x. Y will become dy by dx equals to x power 4 will become 4x cube plus 2 into x square will become 2x, x will become 1. We'll see once again, I need the derivative. When I want the slope, find out dy by dx. So, y when I differentiate with respect to x will become dy by dx. X power 4 formula 4x cube. Remember this, x power n derivative is n x power n minus 1. Applying the formula, x power 4 will become 4x cube, x square will become 2x and x will become 1. This reduces to 4x cube plus 4x minus 1. What I want is slope. You denote slope as m, which is dy by dx at the point x1, y1. That is, in the expression, wherever x is coming, put 1. Wherever y is coming, put 2. So, here I get 4 into x cube is 1 cube plus 4 into x value is 1 minus 1. Simplifying this, 4 plus 4 minus 1, or it is 7. So, we will say slope of the tangent is equal to 7. So, it's a very simple procedure. Given x value, you find out y and find out the point. Whatever is the equation given, differentiate. Wherever x and y are coming, substitute the point. So, dy by dx at x1, y1 is called slope of the tangent. Subsection 2, x is equal to a cos cube t, y is equal to b sin cube t at t equals pi by 2. For slope of tangent, we need to differentiate. Here, I have t. So, we will write differentiate with respect to t. So, I can find dx by dt. I can find dy by dt. But what is my question? Dy by dx. So, how will you write dy by dx? It is nothing but dy by dt divided by dx by dt. LHS is x, RHS is t. You can find dx by dt. LHS y, RHS t. You can find dy by dt. Then how to find out dy by dx? It is dy by dt divided by dx by dt. So let us find out what is dx by dt and dy by dt. So x will become dx by dt equals to a cos cube. We have to remember chain rule. When the power is 3, we have x power n derivative is n x power n minus 1. So, cos power 3t will become 3 cos 3 minus 1, that is 2t, into cos, I have to differentiate. Cos x derivative is minus sin x. So, cos t derivative is minus sin t. See, formula I write with what we learnt last year with x. But here it is all with t. So, apply for t also the same thing. Instead of x, t will come now. So, first x power n will become n x power n minus 1. 3 cos power 3 minus 1 into t. Then cos will become hide power 3. Cos t will become minus sin t. Similarly, dy by dt. Keep b as it is. Sin cube, same pattern. 3 sin square t into, what is sin t derivative? Sin t will become cos t. So, sin will become cos t. First the power 3, then hide the power 3, I get sin t, differentiate sin t. Substitute in the formula, dy by dx equals b 3 sin square t into cos t divided by minus symbol 3 a cos square t into sin t. See what all gets cancelled. Write the remaining. I have 3 cancel. So minus b by a. One sin also cancels, sin t. One cos gets cancels, cos t. My question is m. What is m formula? Dy by dx at the point t equals pi by 2. So minus b by a sin pi by 2 by cos pi by 2. Cos 90 is 0, whereas sin 90 is 1. Denominator 0 comes, I will say my answer is infinity. So slope is undefined for this problem. Exercise 7.2, question number 2. Find the point on the curve y equals x square minus 5x plus 4 at which the tangent is parallel to the line. First of all, let us find out slope of this curve. How to find out slope of the tangent? We have to differentiate with respect to x. Y will become dy by dx, x square becomes 2x, 5x will become 5, constant will become 0. The next step, m equals dy by dx at the point x1, y1. No point is given. Treat it as x1, y1. So, m is equal to 2x1 minus 5. This is from the curve that I have derived. Now, from the line, what is given? Tangent parallel to 3x plus y equals 7. Parallel lines tell me they have same slope. What is slope formula? Minus coefficient of x by coefficient of y. Or I get slope equals minus 3 by 1. That is minus 3. From this slope, which is also m, because tangent and the line are parallel. That implies tangent slope is slope of the line. Now both are m only. Compare. Call this as 1 and call this as 2. Comparing 1 and 2, we get 2x1 minus 5 equals minus 3. Both are m. Both the right hand side we have verified. 2x1 equals minus 3 plus 5, or 2x1 is 2, so x1 is 1. As I derived x1 is 1, let me substitute in the curve equation to get what is y. So y equals x square minus 5x plus 4. When x is equal to 1, y equals 1 square minus 5 into 1 plus 4, or I get 0. So the question is, find the point at which the tangent is parallel to the line. So the required point is x value 1, y value 0. So 1, 0. Exercise 7.2, question number 4. Find the points on this particular curve for which tangent is horizontal. What do you mean by the word tangent is horizontal? Here we have drawn x-axis, y-axis, origin. Tangent is horizontal. Tells me dy by dx is equal to 0, because I cannot measure any angle between whenever they are parallel. X-axis slope only I have to write. So x-axis, y is perpendicular. So we say dy by dx is 0. Remember, whenever tangent is horizontal, it will be parallel to x-axis. In that case, dy by dx equal to 0. Use that condition to get the point. Now given the equation, let us differentiate with respect to x. Y square becomes 2y, y becomes dy by dx. Y square becomes 2y whenever y comes dy by dx. Minus 4 into. It is in product. Keep the first term, differentiate the second term. Plus, keep the second term, differentiate the first term. Keep x, y will become dy by dx. Plus, keep y, x will become 1. Equals to x square becomes 2x, 5 is a constant which becomes 0. Now simplifying this, 2y dy by dx minus 4x dy by dx minus 4 into y, 4y equals to 2x. Keep dy by dx terms in the left, the remaining to the right. So I get dy by dx into 2y minus 4x equals to 2x plus 4y. So what is dy by dx from here? Dy by dx is 2x plus 4y divided by 2y minus 4x. Throughout I can cancel 2 table. Removing 2 from all the terms, it is x plus 2y plus y minus 2x. What is given now? Tangent is horizontal. So whenever I say tangent is horizontal, it implies dy by dx equals to 0. If I put dy by dx equals to 0, x plus 2y by y minus 2x equal to 0, or x plus 2y equal to 0. Whenever I say 0, numerator only is 0, because as I cross multiply. So wherever x is coming, I can put minus 2y. Now substitute this in the given equation of the curve. What is the given equation of the curve? Y square minus 4xy equals x square plus 5. Wherever x is coming, let me put minus 2y. So y square minus 4, x becomes minus 2y into y, and x square becomes minus 2y the whole square plus 5. Simplifying, y square plus 8y square equals 4y square plus 5. Bringing all the terms to the same side, 4y square plus 5 minus y square minus 8y square equal to 0, or I get minus 5y square plus 5 equal to 0, or minus 5y square equals minus 5, y square equals 1, so I get y equal to plus or minus 1. When y is 1, find out what is x. Again, I have to substitute in the same old equation, or I can substitute in x is equal to minus 2y. X is equal to minus 2 into 1, or I get minus 2. So what is the point? Minus 2 comma 1. Put y equals minus 1. X is equal to minus 2 into minus 1, or I get x is equal to 2 comma minus 1. So the question is, find the points on the curve. Tangent horizontal tells me dy by dx equals to 0. Putting dy by dx 0, we get x as minus 2y. Put x as minus 2y in the equation and we get y is plus or minus 1. When y is 1, find x. When y is minus 1, find x. So the required points are minus 2, comma 1 or 2, comma minus 1, and that is the answer. Exercise 7.2, question number 6. Find equations of tangent to the curve for which tangent is orthogonal with x plus 12y equals to 12. As usual, the same procedure, y equals 1 plus x cube. Differentiate with respect to x. Y becomes dy by dx equals 1 is a constant that becomes 0. X cube becomes 3x square. Now, this is with respect to the curve. So, m equals dy by dx at the point x1, y1. So, I get 3x1 square. Second condition, orthogonal to. What is the line given? X plus 12y equals to 12. Slope, what is the formula? Minus coefficient of x by coefficient of y, that is minus 1 by 12. But now the word orthogonal tells me m1, m2 equal to minus 1, or orthogonal slope is minus reciprocal. So whenever I say the word perpendicular or at right angles or orthogonal, they are all one and the same, which tells me the slope is minus reciprocal. So we find out minus reciprocal tells me minus 1 minus reciprocal is plus 1 by 12. So I write plus 12. So minus 1 by 12 is the slope. When I say minus reciprocal, I get the answer plus 12. Compare both the slopes. Call this as number 1 and call this as number 2. 1 comma 2 implies 3x1 square equals to 12, or x1 square is 12 by 3, that is 4, x1 equal to plus or minus 2. Once I know x value, put them back in the equation of the curve. So put x1 equals to 2, y equal to 1 plus x cube, or it is 2 cube is 8, that is 9. So the point is 2 comma 9. When x1 equal to minus 2, y equals to 1, x cube is minus 2 the whole cube, or I get 1 minus 8, which is minus 7, and so the point is minus 2 comma minus 7. As I know the 2 points, let me write the equation of the tangent. So equation of tangent, the formula is y minus y1 equals m into x minus x1. So at 2 comma 9, let me write first. Y minus 9 equals, what is m actually? M value is, here we have written 12. 12 into x minus 2. Y minus 9 equals 12x minus 24, bringing all to the same side. 12x minus 24 minus y plus 9, 0, or 12x minus y minus 15 equal to 0. That is the first equation. The second equation, let us put minus 2 comma minus 7. So as I put minus 2 comma minus 7, y minus of minus is plus 7. M value 12 only. X minus of minus 2 is plus 2. So y plus 7 equals 12x plus 24, or y plus 7 minus 12x minus 24 equal to 0, minus 12x plus y minus 17 equal to 0. Simplifying the answer, 12x minus y plus 17 equal to 0. So we get the two different equations. One is 12x minus y minus 15 equal to 0, and the other is 12x minus y plus 17 equal to 0. Exercise 7.2, question number 7. Find the equations of tangents to y equals x plus 1 by x minus 1 parallel to this line. So we proceed in the same way. The only thing is derivative of this. This is of the pattern u by v. We take u as the numerator and v as the denominator. U dash. Differentiate this. X will become 1. 1 will become 0. V dash. Again, x will become 1. 1 will become 0. And what is the formula? U by v, the whole dash is vu dash minus uv dash by v square. Substitute this step in the question. So my question is y equals to x plus 1 by x minus 1. Differentiating with respect to x, which is in the form of u by v pattern, we have applied the formula. Y becomes dy by dx, and the right hand side apply in this. V u dash. V is x minus 1, u dash is 1, minus u v dash. U is x plus 1 and v dash is 1. See, it is like this way, crossing for this formula. Divided by v square. What is v? X minus 1 the whole square. So v u dash minus u v dash divided by v square, which we have applied. Let me simplify. So dy by dx is x minus 1. There is a minus symbol. Take it in. Minus x minus 1 divided by x minus 1 the whole square. X and x cancels. I get minus 2 by x minus 1 the whole square. What is the slope? We say dy by dx at the point x1 comma y1 minus 2 by x1 minus 1 the whole square. Call this as number 1. So from the given equation, we differentiate and arrive at the slope. What is the second clue given in the question? Parallel to. So we write tangent parallel to x plus 2y equal to 6. So what is the slope of tangent? Minus coefficient of x by coefficient of y, or it is minus 1 by 2. Call this as number 2. Comparing the two, 1 and 2 imply minus 2 by x1 minus 1 the whole square is minus 1 by 2. Cross multiplying. Here I take minus and minus cancels. X1 minus 1 the whole square is 4, or x1 minus 1 is plus or minus 2. Whenever I am taking square root, remember to put plus or minus. x1 equals plus or minus 2 plus 1, or x1 equals plus 2 plus 1 is 3, minus 2 plus 1 is minus 1. As I get x values, substitute in the given equation. Get what is y. x1 is 3, y is equal to, x1 is minus 1, y equal to. Let us substitute. What is y actually? X plus 1 by x minus 1. So 3 plus 1 by 3 minus 1, 4 by 2 is 2. When I put minus 1 plus 1 by minus 1, 0 by minus 2, that is 0. So first point I get x value 3, y value 2. Second part, x value minus 1, y value 0. The question is not the points but the tangents. So proceed with the tangent equation. So what is equation of tangent formula? It is y minus y1 equals m into x minus x1. Treat this as x1 y1. Y minus 2 equals m value already we have derived here. It is minus 1 by 2. X minus x1 value 3. Cross multiplying, 2y minus 4 is minus x plus 3, or bringing everything to the same side. 2y minus 4 plus x minus 3, that is 0, or x plus 2y minus 7 is equal to 0. Similarly, let us substitute this point. This is x1 and this is y1. Y minus y1 is 0. M is minus 1 by 2. X minus of minus 1 is plus 1. Cross multiplying, 2y equals minus x minus 1. Remember, there is a minus symbol. Multiply with both. Minus x minus 1. Bringing all the terms to the same side. 2y plus x plus 1 equal to 0. So we get the two equations of tangents as x plus 2y minus 7 equals to 0 and x plus 2y plus 1 equals to 0.